So, thanks for coming. I'm Georg. I'm happen to work on Tor Browser, and as Fredrik said, on the deterministic builds. So, we just heard from Philipp what kind of game this is, detecting bad relays. And wouldn't it be smart if you had kind of a tool for the user to be protected, be more protected? And it turns out we have one. It is called a Tor Browser. You might, no, it was backwards. You might ask yourself, why do we need a whole new browser for this kind of detection or protection? Well, it turns out we had first a Firefox extension called Tor Button, which basically is, as the name says, a button in your Firefox browser, and you can toggle on and toggle off your Tor usage. And this turns out to be a really bad idea for a couple of reasons. The one reason is it doesn't fit to the mental model the user have for how the browser is working. Imagine you have couple of tabs open in your browser, and it turns out one of these particular tabs has a website in it, and this website is blocking Tor. But you really want to visit this website today or now. And what you're doing with the toggle model Tor Button had was you just switched off Tor. You visited the website, but then you just forgot to enable it again. So you shot yourself in the foot. And the other issue is, while the Firefox API is quite powerful, it is still not powerful enough for our purposes, because there were still privacy issues with certain Firefox features which were not patchable from Tor Button itself. So Mike Perry set out to take the huge task on his shoulders and maintained a Firefox fork for quite a while, almost alone, and which basically is now Tor Browser. It is based on Firefox because Firefox is a free and open browser, and we have the capability to audit it and audit its features and write patches and can distribute it. You might think, why not using Chromium or Chrome? Because you might have heard that they may have a better track record regarding security features. Well, the latter might be true, but the Chromium people are not really willingly to fix some nasty leaks they have in their browser regarding privacy and proxy behavior. For instance, they have a proxy bypass. They're using the crypto API on Windows, and it happens that this usage of the crypto API in Windows is bypassing your proxy settings in your browser, and there's nothing we can do about this. And they even are not willing to fix this issue. It's not important enough to them. So we stick to Firefox. So another thing is, if you really want to use the Tor network safely, how can you be sure that you really get the Tor browser we produced? Well, the first point is it's download over HTTPS. This is almost a no-brainer, of course. And if you have a recent enough browser, you get even certificate pinning of our websites, which is nice. But then we have additionally signed these bundles with Tor browser developer signing key to give you the opportunity to verify these bundles on your own machine. But you might think about the updating things. What am I doing if I need to update my browser? And this happens actually every 6 weeks now, because Firefox switched to a rapid release schedule as well. So the old school way would be downloading every 6 weeks a whole browser and verifying it again, and importing your bookmarks again and doing all the customizations. So what we did is we patched the Firefox updater to work with our system, and you are getting now updates every 6 weeks. automatically. And these updates are currently only safeguarded by HTTPS basically, and we have a kind of certificate authority pinning in the browser. But this is going to change in 2 weeks when the new stable release is coming. So, but even then, what gives you, maybe you're more adventurous in saying, well, I don't care about these HTTPS things. I just download the source, verify the text, and build all the things myself on my laptop, my computer. Well, you could do this, but you probably won't do this because it's quite tricky and it's quite complex, and you have actually the bundles just one download away. So, but if you think further, what gives you the certainty that there is a direct link between the source code and the binaries you get, right? What happens if our building machine is compromised? What happens if one of the developers who holds the signing keys thinks, well, let's put malware in it and sign it anyway? So Mike Perry again sat down and took the task to establish deterministic builds for Tor Browser, for all platforms. Deterministic builds, I'm not talking about this much because it's actually an old talk, because it's such a huge topic. But the Bitcoin people developed deterministic builds, which give you bit-by-bit identical outcomes of a certain source you put in, which is maybe obvious to some, but maybe not obvious, I don't know. Anyway, it is a property which is really nice to have, because then you can have dozens of different people building on different machines, and they all agree on a certain Tor browser at the end, because they all have bit-by-bit identical builds. And you can be pretty sure that you don't have one compromised build machine. It's pretty hard to compromise all of those machines if you have a bunch of builders. So, what are the key features of Tor Browser? It is basically a self-contained portable app. You download it, you put it on your computer, and you extract it and you start it and you can use it. And then if you don't want it anymore, you just put the folder in your trash and then all of it is gone. There are no disk activity records by default, meaning if you have it on your USB device or a USB stick and you put it on a computer of a friend and you start it, then it won't happen that your personal data or things are on your computer of your friend. It's still only on your device. Then two things we have, which I'm going to talk a bit more in detail later on, is third-party tracking prevention and browser fingerprinting defenses. And we have censorship circumvention. There are people like in countries like Iran or China which cannot reach the Tor network because the governments there have firewalls and other censorship equipment which prevents this. So we have developed so-called pluggable transports which obfuscate traffic in order to make it much trickier for those governments to detect Tor traffic and block Tor traffic. These pluggable transports, Philipp wrote one actually, are part of Tor Browser. Okay, if you happen to be in such a country and your traffic gets blocked, then you can switch easily to one of those transports and you can surf on the Tor network, over the Tor network. And we have some browser security enhancements. Mainly things like hardening our binaries against buffer overflows and things. So the components are, as I said, a Firefox. We don't have the normal Firefox. We have the Enterprise Edition, which switches actually every 10 months, and in between they only have security updates. It's much more conservative code base to evaluate than following all the time the rapid release Firefox has adopted. Of course we ship Tor. Then we ship Tor Launcher, and as the name already says, that's the part of the Tor browser that is launching Tor and is controlling Tor and talking to Tor. Then we have the already mentioned Tor button, which gives you some control over your privacy settings. It tells you that everything is okay with your browser and checks for updates and things. Then we have an interesting tool called HTTPS Everywhere. This is one of the things that makes your Tor browser much more much better to use than a normal Firefox if you have these bad exit relays in mind. What this tool is doing is it is transforming HTTP requests into HTTPS requests if it has a rule inside a database which is shipped with it for rewriting these kind of domains. That means you go to http://a.com and HTTPS Everywhere is looking into its database and see, I have a rule for reaching a secure website, or this domain securely, and is applying this rule. And before the request is going over the wire, it is rewriting this to https://a.com and just requesting the secure version directly. Then we have NoScript. NoScript is usually used by us for easy use of or for easy possibility of disabling scripts or handling your media content. And then we have the so-called pluggable transports. So I don't plan to explain all those tracking defenses and fingerprinting defenses in detail. What I want to convey to you is our broader philosophy and giving you a hint how we are doing this and how we are implementing this. Because this Tor browser is actually kind of a prototype, and this one intention is to urge other browser developers to apply this philosophy we have in mind in order to give not only Tor users a private browsing experience which deserves its name, but all those other users as well. So what we want to do, we want to preserve the existing user model. This is one really important point to make here, because Tor button is, as I said earlier, is one of its obvious failures of this preserving of this existing user model. What I have in mind here is users usually have a mental model of how browsers are supposed to work. You know, they want to have multiple tabs. They want to know if I click this button, this is happening. They want to have bookmarks and all those things. And if you develop a browser that is basically against this kind of mental model, then users are going away. And if users are going away, you have only a small user group, right? Like a couple of users, a dozen of users. But this makes it much more easier for attackers to single you out. So you need a large user base in order to be able to hide among them. Then, additionally, we want to have an implementation of a privacy enhancing technique in a way that it's not likely to break websites. Because, I mean, if it's easy to lock a browser down in a way that it's almost secure and almost no privacy invasion can happen. But if you have such a locked down browser, what is happening is, again, you have just 6 or 7 or 8 or 9 or 10 users which are able to still use the web, because all the other people want to have your Facebook or want to have Twitter or whatever, and this is going to break definitely in this locked down browser. So what we want to have is implementations that while guarding your privacy give you still the usability of your normal browser experience. Then, important point is plugins must be restricted. Plugins are actually really evil because plugins can easily bypass as well the proxy settings in your browser. So we made a patch for the Tor browser that restricted plugins in a way that you're even not allowed to load plugins into your process address space. One exception is Flash, because Flash is still widely used. While we don't ship it, we give the user the opportunity to still enable it, but you must jump through several hoops in order to do so. Then another lesson of the Tor button area was that we need to minimize the global privacy options, because if you have dozens of options, it's very likely that you are clicking on some things, forgetting things about it, and then you have a unique kind of set of options checked, and it's pretty easy to single you out while you're serving the web. An important point to me is the next one. We have a no filters policy. You might have heard some people or companies claiming that in order to have a private experience on the web, you have to use some filter software like ad blockers, right? Like Adblock Plus. Or Mozilla recently launched the Polaris thing, and they think they want to have kinds of blocking lists as well, which is filtering out the advertisements, because they think if we got rid of the ads, then we are fine with regarding privacy in the web. So there are a couple of points to make here. The first thing is, who decides which sites are coming on those lists? Who is controlling those people who are saying these ads are bad to us? So we don't want to get in this business. We want to say we want to have a private privacy by design solution which doesn't take care of these ads thing in particular. Because, I mean, even if those ads are gone, imagine an internet where you don't have ads. The underlying tracking opportunities are still there. So that means you can get rid of all those ads, that's fine. But still, you're getting tracked by people who don't want to sell you things, but using the same underlying mechanism. So that's why we are thinking it's wrong to jump on this no filters train. And apart from the fact, maybe there are really some small companies or medium-sized companies or whatever which are really have a legitimate business model based on ads, on certain kinds of ads. You would destroy these business models for no good. And the last one is stay up to date. It just doesn't mean that you have to update all the time. Yeah, that's a given. But updating, stay up to date means as well that you keep an eye out for upcoming problems in order to be able to react swiftly. And then this gives you more time to audit new technologies, new features, and develop defenses. Okay, tracking protection. So what we are concerned with is tracking across different domains. That means you're visiting in one tab, let's say site foo.com, and on the second tab, site bar.com. And what we want to achieve is that people who have embedded things on both sites are not able to correlate the traffic of you. So the technical terms are that you want to have bound all those identifiers to the URL bar domain. This is our solution. The easy one would be we just disable all those third-party tracking techniques like third-party cookies or third-party cache state things or DOM storage, third-party DOM storage things or stuff. But as I said earlier, that would be really devastating to some of the functionality we have currently in the web, which gives you basically users who are unhappy and are leaving you. So our solution is we separate state by saying all the things that are saved while you are saved on your computer, like cookies or cache state or DOM storage or HTTP authentication credentials. All those things that are saved on your computer while you're visiting food.com should not be available to bar.com, which is a different domain. So they are bound, all those identifiers are bound to the URL domain. And if this is not possible, because if you look at these at this slide here, I have some curly braces here, and these curly braces indicate things which you don't have tackled yet, like third-party cookies. There's a patch we have, but it's not ready for prime time yet. So if we have things which we haven't fixed, then we try to disable this feature, like third-party cookies or flash cookies in this case. How should this look like at the end? The goal is to have such a kind of privacy user interface where you only have the top level domains you have visited, and then all those data that is stored on your computer is behind this icon basically. And then you can use it normally, like remove this data or clear site tracking data, but it's site-based. And this has the advantage that it's basically leaving the functionality. The site is totally still working. If you have, for instance, captchas, which is using some kind of third-party provider like reCAPTCHA, this is still working, but across domains you're not trackable anymore. So fingerprinting is a different beast. Fingerprinting basically means that people are checking if you are visiting a site with a certain device, like a certain laptop, because it is capturing screen sizes and your user agent of your browser, your headers you send, even your time zone. So it's easy for JavaScript, for instance, to extract your time zone. Our idea is to say, we want to have users as uniform as possible in this regard. This means we try to return the same values for everybody. Like the user agent is a good example. Your Firefox or whatever browser you're using is telling the server, hi, I'm, for instance, a Firefox, I'm on version 31, and I'm on a Windows system, and then the server is saying, that's good, and it's maybe acting on it and sending proper data back. But what we are doing is we give every user the same user agent, regardless if she is using a Linux box or a OS X box or a Windows box. The same happens with HTTP headers. The same happens actually with the time zone. So we are setting the time zone to UTC. Everybody who's using Tor Browser is on UTC. And again, the curly braces, we are trying to do the same with fonts, because fonts is a really nasty, fingerprinting via fonts is a really nasty technique, because the system fonts you have on your computer are highly identifying. So what we are thinking is shipping the Tor browser with a pre-configured set of fonts, which everybody gets, and which eliminates this kind of fingerprinting vector. So if this is not working, then what we are going to do? First we try to put users in different buckets, you can say, like in different groups. This happens, for instance, for the screen and window sizes. So if you're starting a Tor browser, we are rounding your window sizes to a multiple of 200 and 100. This gives a bunch of different buckets, which hopefully has a lot of users in each of these buckets in order to make it much harder to single users out based on their screen sizes. If this idea is not working as well, then we are disabling things. There's a bunch of things I wrote here, and a bunch of things which is missing. We disable, like plugins, as I said. And the gamepad API is a funny thing. There's an API which allows the browser to enumerate your USB devices you have on your computer attached. Then there's a possibility that you that the browser that a server is fingerprinting your open ports on your network and things like this. So still, we have talked about cross-domain tracking and fingerprinting. There's still a thing which is really worrisome, because there are powerful trackers out there which you are actually acting on a day-by-day basis directly. So not cross-domain, which is handled by those things I talked earlier about. But you're talking directly to your favorite search engine. That means it gets the opportunity to save cookies on your computer and save other cache cookies and other state on your computer. And basically, if you never take care of this data, it gives the search engine, for instance, a high opportunity to profile your traffic and reveal some patterns you might not ever know yourself about. So what we want to do to tackle this issue is we want to take care of this long-term unlinkability via a button called new identity button in this case. And what this new identity button in the Tor browser is doing, it clears all linkable identifiers and browser state easily. So it gives you a clean blank slate again. And it gives you even a new Tor circuit, meaning that you are having with high probability, a new exit node. So that even Google can't correlate things anymore based on IP address or other things. So the future is bright. The next stable release is coming actually in 2 weeks. And we implemented a feature in this one that Tor circuits are bound to the URL domain now as well. That means if you are going to a.com, then you're going via a certain circuit. But if you're going to b.com in a different tab, for instance, then you're taking a different path through the Tor network. That makes it much, much harder for exit relays to correlate your traffic. Before this, the problem is that all your browser traffic is usually going to through one of the exit relays in a time frame of 10 minutes. So what we are doing is we are switching the exit relay every 10 minutes in order to minimize or make it less risky that the exit relay is correlating all your browser traffic. And what we are going from the next release on is binding these domains to binding Tor circuits to domains as well to make this correlation much harder. Then we have another feature is this security slider, so-called security slider, which gives you the opportunity to handle your different security how should I name it? Security purposes you have or security feelings you have in the same way. You have a slider. This is basically the bucket idea I had mentioned earlier, where you have 4 positions actually, which is setting certain kinds of preferences in the same way, and you can hope that you have a lot of followers in your bucket. And you can, for instance, in the high security setting, the high security setting is disabling JavaScript and making all those media things click to play and giving you other benefits as well. Then we have eventually the Tor browser updates signed by a key as well. So you're not only relying on HTTPS anymore, but the bundles are signed as well, and they are later on even checked via the Tor consensus too. And we are planning actually so-called hardened bundles for the end of the year, which has some interesting features. They are built with address sanitizer on and some memory hardening techniques, and they are supporting Unix domain sockets in a way that lets you, at least on Linux and on OS X, disable the whole network stack and just communicate with your Tor instance via these Unix domain sockets, which makes it much, much harder to leak accidentally network requests. So we have some conclusions prepared. They're basically almost obvious, I think. So you should use Tor Browser by default. This is the most sane thing, actually, what you can do at the moment if you want to surf over the Tor network. The problem of bad access is not negligible, but it's, as Philipp said, also blown out of proportion. If you look at how many access relays we have, how much effort we take detecting them quickly and disabling them quickly, and how much protection Tor Browser is giving you. And as you have seen, at least in my talk, about all those curly braces showing up here and there, and all those ellipses I made for leaving things out, there's help needed in many areas because it's a huge topic and it's important for users. So, thanks for coming. We have some stickers here, and I think we are now up for some Q&A things.